Today, we're going to look at circles. Circles are probably the simplest of the conic sections, and it's going to be our first conic section that is always, or let's put it this way, circles are our first conic section that is never a function if we're talking about the graph of the entire circle. So what I have right here is I have a circle with a radius of 5, and I have the equation for the circle set up. You can see it on the screen there. Y squared plus x squared equals r squared. Often I'll write it the other way, x squared plus y squared, because addition is commutative. You can write those variables in either order. R in the equation represents the radius. So right now R on the slider you can see is set to 5. So that means our circle has a radius of 5. And you can see that it hits the y-axis and the x-axis at these points, all 5s and negative 5s. And once again, a circle, if we're talking about just the definition of a circle is the set of all points that are the same distance from an imaginary point called the center. So in this case, this circle is the set of all points that are a distance of 5 away from the center. And all the circles we'll be looking at today will be centered at the origin, will be centered at 0, 0. So as we can see here, we have a circle. I mentioned that a circle is not a function. On the graph, you can see that it does not pass the vertical line test. In order for something to be a function, you should be able to draw any vertical line and have that vertical line pass through no more than one point on the circle. I can insert a vertical line here. X equals 1. We see that it intersects the circle at 2 points, meaning this is not a function. Desmos, one of the great things about Desmos is that we can graph things. We don't have to write them in function form. But I will show you in a little bit how you can sort of write this as two different equations and write it as two separate functions. Okay. Now, once again, r is our radius. So we could change the shape or the size of the circle simply by changing the value of r. So as r gets smaller, obviously the circle gets smaller. And as r gets larger, that circle gets larger as well. Because r is being squared, technically you could think of r as having a negative value because it becomes squared and it's a positive value, but that's not something that we'll really spend any time doing. We're always going to think of that radius as a positive value. Distance. That idea of distance, you should usually think of it as being distance being positive.